All right, so last time we started systems of equations in 3 variables, and we took a look at this example, and it was fairly friendly actually, because there were not actually 3 variables in all 3 equations, and so that was kind of nice. And I mentioned that the basic idea of how we eliminated something to get it down to more manageable pieces is exactly what we're going to do, even on this one when we start out with more going on. Our goal is still going to be to get it to a point where I have fewer variables in an equation and I can solve an equation that way. So when we did systems of 2 equations, one of our methods for doing that, for solving them, was called elimination. You guys remember that? And in elimination, the goal was to get to get one of the variables to match coefficients, where one of them was positive and one of them was negative. For example, on this slide right here, the first equation and the last equation have that same component going on with the variable x. Do you guys see that? One of them is positive, one of them is negative. So if I were to add those 2 equations together, I would eliminate my x, right? Okay, so that's what we're going to do, is we're going to take equations 2 at a time, and we're going to eliminate a variable. But we got to choose what variable to eliminate first. So you need to look at either all the x's, all the y's, all the z's, and decide, I'm going to eliminate and pick a variable. So let's pick one together. I don't know if it's going to follow what I did when I made my notes, and that's totally fine. We'll just be careful when we're working. But pick a variable that you'd like to eliminate, x, y, or z. X. Okay, so our goal in sort of step 1 of this is going to be to eliminate x. And I mentioned last time that I find it easier, or I find it nice, to label my equations to keep track of them, okay? So it is actually pretty nice to take equation, so our sort of a sub-goal here is to eliminate x, right? That's our point of what we're doing right now. And it is actually really nice to take equations 1 and equations 2 and simply add them together to do that, right? I can take those 2 equations and I can eliminate an x. So I have x plus 3y minus z equals negative 3. And then I have negative x minus 4y plus 3z equals 6. And just like with 2 by 2 systems elimination, we add them together. The x's are going away, which was our goal. And I'm left with negative y plus 2z equals 3. Okay, so it doesn't just have 1 variable, it still has 2, but 2 is better than 3. What's that? Which one? Oh, yes, I labeled it wrong. Thank you. Yes, 1 and 3. Thank you. Yep, you're right. Okay, is that good? Okay, I still have to take 2 equations and do the same thing again, and they can't obviously be equations 1 and 3, or I get the same equation. That doesn't work. I need to either take equation 1 with equation 2 or equation 2 with equation 3, and it doesn't matter which one, but one of them potentially would be nicer than the other one. Okay? So if you're looking at equations 1, 2, and 3, and I can't pick 1 and 3 anymore, what 2 would you like to pick to eliminate x? We're still eliminating x. 2 and 1. Okay, so these are the 2 that Keely suggested, and I agree. Those seem like the most natural. If I just add them together as is, they won't eliminate x though, right? What am I going to have to do? What am I going to have to do in order to eliminate x? Right. So your notation can be whatever feels comfortable to you, but what I usually do is I just write a note to myself that I'm multiplying by 2, and I'm working with equation 1. So on equation 1, if I multiply by 2, I have 2x plus 6y minus 2z equals negative 6. That's equation 1, after I've multiplied by 2. Equation 2 can simply be rewritten as is, negative 2x minus 2y plus z equals 8. And we do the same thing again. We add the equations together to eliminate the x, and then I will end up with 4y minus z equals 2. Okay, good so far? So here's the net result of what happens. I now have 2 new equations, but they only have 2 variables in them. I'm going to call them equations 4 and 5, just to give us a reference point. I'll put it after them, actually. This will now be our equation 4. This will be our equation 5. Okay, but we just spent 2 sections worth of material on how do I take 2 equations with 2 variables and find x and y, right? So I'm going to do the same thing here again. Now I have 2 equations with 2 variables, y and z, that I need to use to find each of their variable components. What are the letters I'm representing? You get to pick. Do you want to eliminate y or do you want to eliminate z? Z? Okay. So if we are going to now eliminate z, that's sort of the step we're in. If you take a look at the 2 equations that I've highlighted in orange, if I add them together right now as is, that will not eliminate z, right? But what I need to do in order to make that happen? Multiply equation 5 by 2? Sounds good to me. Okay, so equation 4 is going to stay the same. It is negative y plus 2z equals 3. And I'm going to multiply by, did you say 2? 2 to equation 5. So equation 5 multiplied by 2 would give me 8y minus 2z equals 4. So far so good? And of course the whole goal was that that would eliminate my z's. So now I have 7y equals 7. So what's y? 1. Y is 1. If I know that y is 1, can I find z? I should be able to, because I have 2 equations on my screen, 3 kind of, but 2 simple equations highlighted in orange that both have y and z in them, right? I can use either one of them. Is there one that's better than the other one? Second one, equation 5. Okay, so if I use equation 5, which says 4y minus z equals 2, and I plug in y, it'd be 4 times 1 minus z equals 2. So this is 4 minus z equals 2. What's z? 4 minus what's 2? Just 2, right? 4 minus 2 is 2. 4 minus 2 is 2. So now I found z, so I found y, I found z. What do I still need to do? I need to find x. Any of the first 3 equations, 1 through 3, have x, y, and z in them. I now know y and z, so I should be able to find x. Which equation would you like to use to find x? The first one's the nicest. Let's use equation number 1. So equation number 1 says x plus 3y minus z equals negative 3. X is what I don't know. Y is 1 and z is 2. So I have x, this is positive 3 and negative 2, so it's positive 1 equals negative 3. And if I subtract that 1, what will I get? Negative 4. I now have 3 equations, 3 variables solved for, x, y, and z. And how do I write my answer? Yeah, as an ordered triple. So I do x first, that was negative 4. Y second, that was 1. And z last, that was 2. How can I make sure I'm right? Yeah, I could plug it in to check it to all 3 of my original equations, right? Absolutely. And all the ones you're going to be dealing with are going to be friendly variable coefficients for your variables. You're not going to have any fractions or anything with the 3 by 3s. My point is not to stress you out. My point is to take one component, which is the fact that we've had more variables and more equations, and just deal with that. All right? So plugging this in shouldn't take too much. You can grab your calculator and check it if you want to. Let's see if I have the same thing on my book. I do. And I actually eliminated z first, just so you know. So if you've eliminated a different variable first than someone else, that's totally fine. You should still get the same answer, barring any, arithmetic mistakes or something like that happening. All right, I have one more example in this lesson, and because I wanted you to see what happens when you have three equations, but they have sort of a mixture of the x's, y's, and z's. They don't have all x's, all y's, and all z's like the last one, but they aren't quite as straightforward as that first one where we could just, you know, boom, 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 solve for each equation individually. That one was really friendly. This one's kind of a mix of those two. I have x plus 3z equals -1, y minus 2z equals 6, and 4x plus 3y equals 20. Okay, so just like on the last one, the goal's the same. I've got three equations and there's three unknowns. I mean, that's what I have. And I need to somehow reduce it down to two equations and two unknowns. That's what I need to do. So what I need to do is I need to figure out what variable I want to eliminate. Do I want to eliminate x's, or do I want to eliminate y's, or do I want to eliminate z's? And they're not really lined up, so if it helps you to think about them, you know, line them up. You've got x, you've got a blank spot, you've got 3z equals -1. You have a y right here, minus 2z equals 6. And you have a 4x plus 3y equals 20. All right, so if it helps you to line them up to kind of compare the components, it might be able to see it easier. Would you like to eliminate x's, y's, or z's? X's. Y's would be equally good, right? Z's would be unfriendly. Would you agree? I mean, like compared to the others? Yeah, so x's sounds good, Macy. We will eliminate x's. So if I'm going to eliminate x's, then which two equations do I have to choose? 1 and 3, right? Because the second one doesn't have x's already. So it's like we've already got kind of a step ahead. I already have one of the equations 4 and 5 that I created on my last slide found. I just have to find the other one. So we're going to leave equation 2 untouched, and we're going to take equations 1 and 3 and work with them. So what would I need to do to get equations 1 and 3 to eliminate an x? Right, I need to multiply the first one by -4. So we'll take the first equation. Well, actually I did it like this. So we're going to take the first equation and we're going to multiply by -4 to equation number 1. All right, so that's going to give me a -4x. It's going to give me, I'm going to leave the blank spot since I've already done that. And then I've got -12z equals -4. And then equation 3 can stay put. 4x plus 3y. Notice the 3y and then 12z can't combine, so I'm putting them in separate columns to help remind me that. And then when we add them together, lo and behold, the x's go away. And I'm left with 3y minus 12z equals 16.
I have a question.
Yes, ma'am. Should I write something down? Oh, up from here I had a negative off. Yes. 24 here. Thanks. Good job spotting errors, guys. They're harder to see when they're your own. You'll find out on your own when you start working the problems. Cool. This is equation 4. But I'm now down to two equations, 2 and 4, that only have y and z in them. So looking at those two equations, do you want to eliminate y or do you want to eliminate z? You can do z? Okay, so if we eliminate z, what equation do we need to multiply and by what number? The ones that are highlighted in orange. Yep, top equation by -6. So equation number 2 would be multiplied by -6. So equation 2 by -6 would give me -6y plus 12z equals negative 36. And then equation 4, found just a moment ago, is 3y minus 12z equals 24. And of course, these add to 0. I have negative 3y equals negative 12. So what is y? 4. And I have one of my three variables solved for. Y is 4. Which variable would I solve for next? Actually, which variable would you like to solve for next? You have a choice on this one because you have lots of equations on your screen, actually. Some of them have x's and y's, and some of them have y's and z's, and these are all kinds of equations. So which one would you like to solve for next? You want to use equation number 2? Okay, so you want to solve for z. Is that the one you mean? Okay, sounds good. Okay, so if I use equation number 2, I would be using y is 4. So y minus 2z equals 6. If you don't like her choice, you can choose something different and check it out and make sure you get the same thing we do. It would look like that. So if I subtract my 4 to the other side, I end up with negative 2z equals 2. So z is negative 1. Have a z value, I have a y value, so the only thing left is x. Which of the three equations? The first one would probably be the nicest. All right, so equation number 1 has x plus 3z equals negative 1. X is what we don't know. Z is negative 1. So this is x minus 3 equals negative 1. What is x? It's 2. And your ordered triple then is 2, 4, negative 1. All right, any questions on that? We're going to do a couple more in the next lesson, but they'll start at a different place to start with. All right.